Good afternoon to everyone. How are you? Okay. So in each and every class, I do not need to introduce myself. I thought you all were aware of my name and which subject I'm teaching to you. Okay. So as the class has to be move on. Yeah. Just a second. Give me a second. Okay. Okay. So here we are with the continuation in the lecture of geometrical optics. So if my screen is visible to you and I'm audible to you and I'm also visible to you, then give me a thumbs up or write it in the chat box very soon. Okay. बहुत जल्दी. Just a second. There is some technical glitches that I'm encountering. So just give me 1 to 2 minutes. Okay. The screen is not coming. That is the problem. Sorry for keep you guys waiting. ठीक है. Screen visible हो जाए, then I'll be move on. Okay. So here we are. Now the screen is visible to you all. Just write it in the chat box if this is visible to you. Please guys write it in the chat box if the screen is visible and I'm audible to you. Okay. Okay, Swati, thank you. So we will move on to the our lecture, which is the continuation of geometrical optics. Okay. So we are with the lecture number 4 we have. Okay. So let's move on. So this is our geometrical optics lecture number 3. Again, this is the mistake that I have made here. Yeah. So firstly, we are going to do the recall. Then we are going to discuss about the nature of image. Then we have to do image formed by spherical mirror. Okay. Then refraction, refractive index and laws of refraction. This refractive index term is related to refraction. Okay. So we are going to discuss it as well. And then laws of refraction, it comes multiple times because I have to say something more about the laws of refraction. That is why I have mentioned 2 times it. Okay. Then the path of reflection in glass slab or lateral shift. Okay. So let's move on. Are you guys ready? Yeah. So firstly, we will recall some concept that we have learned so far. Is firstly that in the previous session we have done with spherical mirror. Spherical mirror is nothing but a part of a sphere. Okay, a glass sphere we can consider. And if we cut it, okay, not perpendicular, not in the line passing through the diameter, but somehow shifted position. Okay, if we cut this, then we have two surfaces. That one of the surfaces is called the concave surface, and one of the surface is called the convex surface. The outer part of the sphere is termed as the convex surface, and the inner part of the sphere is termed as the concave surface. So based on these two surfaces, we have two spherical mirror, concave mirror and convex mirror. Concave mirror is that when the reflective surface is concave, okay, when the inside part of the sphere is reflecting and outside part is polished, okay, यहाँ से रिफ्रैक्शन नहीं हो सकता, reflection. Only this surface can cause the reflection, means the inside, the concave surface. Then the mirror is termed as concave and vice versa. ठीक है. Convex के लिए the convex part of the sphere, convex part of the surface has to be reflected one. ठीक है. Inside part will be polished. ठीक. Then yeah, this is the example. अगर पिछले में कंफ्यूज हो रहे हो तो यहाँ से इजीली समझ सकते हो. ठीक है. So if this surface is the reflected one, that is the convex surface. Just let me change the color of it now. So this is termed as the convex surface if this part is the reflected one. ठीक है. This is the reflected surface. So this reflected surface is convex surface. So this mirror would be called as convex mirror. Got it? And in this part of the figure, this surface has to be reflected. So this is the concave surface. So this mirror is termed as concave mirror. Okay, got it? Now the sign convention part that I have told you. If you move up from the principal axis, like this is your principal axis, this line representing the principal axis. If you move up, it will be positive. If you move down, it will be negative. Okay. If you move in the direction of incident ray, it will be positive. If you move in this direction, the direction of reflected ray will be considered as negative. This is all about the sign convention that you have to keep in your mind. इधर जा रहे हो तो पॉजिटिव, इधर जा रहे हो तो नेगेटिव, ऊपर जा रहे हो तो पॉजिटिव, नीचे आ रहे हो तो नेगेटिव. ठीक है. Obviously this formula applies in life also. अगर आप ऊपर जा रहे हो, this will be positive for you, you are getting success and all. But if you are going down, it will be negative for you in terms of failure and all. Okay. So mirror formula, we have 1 upon f is equals to 1 upon u plus 1 upon v. The derivation part of this we do not need because it is not essential. In JEE, there is no such question has been asked in which the derivation part is to become. ठीक है. Derivation किसी भी question में नहीं पूछा जाता. You know that. ठीक है. So here what is f and what is v and what is u? So u here is the distance of object. This is the mirror we have. We will consider the concave one. This is the principal axis. This is the object we have. Oh, ठीक है. यहाँ पे कहीं इमेज बनेगी. This is I. So ये इसका होता है पोल, the geometrical center of the mirror. Pole से the distance of object will be considered as u, and the distance of image will be considered as v, and focus is nothing but the point of intersection of reflected ray. ठीक है. And the ray moving parallel to the principal axis. What is focus? Focus is nothing but it is a point of intersection. ठीक है. जहां पे जो इंसिडेंट रे पैरेलल टू दी प्रिंसिपल एक्सिस मूव कर रही है आफ्टर रिफ्लेक्शन, at what point they intersect the principal axis is termed as the focus. ठीक है. Like in this example, this is the incident ray coming after reflection, it cut the principal at this point, so this is the focus of the mirror. ठीक है. So we have done with this. What is value of f? F is the focal length also, the distance of focus from the pole. So it is termed as the focal length. Okay. And here f is the focal length in the mirror formula. ठीक है। concave mirror के लिए focus is to be negative because for concave mirror, this is the example of concave mirror, this distance has to be measured in reflected direction. And for convex mirror, like this is the part of convex mirror, I am saying this is the incident ray after reflection is goes in this direction. So if I try to, yeah, this point has to be cut by it apparently. ठीक है, not actually. So this is the focus. To measure the distance from pole, we have to move in the positive direction. So that is why for concave mirror, the focus is negative, and the for convex mirror, focus is positive. Hello Darshana, how are you? Okay, I hope you got this, whatever I have teach you. So here we have a new formula also. The focus is also the half of radius of curvature. I have discussed what is radius of curvature. If this mirror is a part of sphere, the radius of that sphere is the radius of curvature. That is it. Okay. And this formula is valid only for small mirror. ठीक है, mirror को छोटा होना चाहिए. Now move on to the next topic. It is the magnification of linear object. What is the magnification? It is nothing but the ratio of size of image divided by size of object. Okay. So it tells us about that how after reflection, how much the image is magnified. ठीक है. And magnified होने का मतलब ये नहीं कि image कितना बड़ी ही हुई, कितना छोटी भी हुई. ठीक है. This is all tells us the magnification told us. Okay, magnification will also tell us about the nature of image that we are going to discuss in the later part of the lecture. Okay, so from here you can keep this in your mind that magnification is tells us about the nature of image, like how the size is getting reflected, deflected, and how the property of image changes. Okay, this all information is gathered from the magnification. Okay, there are two types of magnification we have: transverse magnification and lateral. What is transverse? If you play, this is the principal axis, I must say. If you place the object perpendicular to it, ठीक है, तो इमेज इसके नीचे बनेगी या ऊपर बनेगी, कैसे भी बने, but you have placed the object perpendicular to the principal axis. At that time, what magnification you calculate is termed as the transverse magnification. Okay, it depends on the height of object and the height of image. Okay, but for the lateral magnification, this is the your longitudinal this is your principal axis. If you place the object like this parallel to the principal axis, along the principal axis, then the magnification is directly dependent on the length of the image and length of the object. So that magnification is termed as longitudinal magnification. Okay, we have a relation between longitudinal and transverse for linear object that uh, uh, just a second, this longitudinal magnification is equals to the square of transverse magnification. Got it? For linear object. Okay. Okay, then velocity of image in spherical mirror, we have also discussed it. Okay, velocity of image, this is the parallel velocity from principal axis के parallel जो है. This is principal axis, this is the velocity parallel to principal axis. So for this velocity, this u and v is going to change. So to derive this, we have used this formula 1 upon u plus 1 upon v. And this is the velocity perpendicular to the principal axis, and this will going to change the height of image and height of object. So we have used this formula in this magnification. Hi over ho is equals to minus of v upon u. Got it? These are the two formula that we have. Okay, now we are going to discuss something about the nature of image. ठीक है, अभी तक किसी को अगर कोई भी डाउट हो, you can ask, otherwise we will move on. ठीक है, you can write this straight in the chat box. This is the concave mirror we have. ठीक है, nature of image directly depend on the magnification. What is magnification? Magnification is nothing but size of image upon size of object. Okay. Suppose in terms of formula, if I write it down, क्योंकि mostly you will deal with the transverse magnification part. Okay. So m is equals to hi over ho is equals to minus of v upon u. Okay. So there are few terms that I want to discuss with you, that for image can be two part. Okay. Real image and virtual image. Okay. How we are going to decide this, that the image formed is real or virtual? How? Because with the help of this magnification. Okay. If there is an object over here, this is O, and this is the image form. Okay. This is I. Okay. So you can see this. If I draw, this is the incident ray, and again this is the incident ray we have encountered here. Okay. So for this ray, you can see here, this image is the actual meeting of reflected rays. Okay. Actual meeting of reflected rays. ऐसा है. So when the rays is actually meet after reflection, the image formed will be real. Is this the way? But not in every situation you are going to draw the ray diagram of the question. Okay. So for that, what you have to keep in mind, that for real image, V is also negative and U is also negative, because you can see in this example, U is also measured in this direction, in reflected ray direction, and V is also measured in this direction. V, the distance of image. So both are negative. If both are negative, put this value in this. For real image, if both the V and U are negative, we have seen this by sign convention method. Here I have discussed it. So what is the magnification? Magnification is nothing but minus V upon U. Okay. What is? It is minus V. Just a second. Minus of minus V divided by minus U. Again, this minus and minus will cancel out. So it will come out as minus V upon U. Means M here is negative. M here is negative. So for real image to be formed, M has to be negative. So if I'm writing it here, if M is equals to a negative value, then real image has to be formed. Real image. Okay? Got it? Similarly, if image formed in this side, the value of V getting positive, okay? Again, put this in. Put the value in this or virtual one. ठीक है. So virtual के लिए V is positive over here. Just a second. V is positive, but U is negative, because you have to place the U on the principal axis. ठीक है. So you have measured in this direction. U means distance U has measured in this direction. So U is negative. Okay. So what this has to become out? Negative, negative, positive. So this has to become out a positive value. So when M is equals to positive, the image formed will be the virtual one. Virtual image has to be formed. Okay. Got it? Got this? If you have any doubt in how to describe the real and virtual nature of image, you can just write it in the chat box. अगर ये समझ में नहीं आया what I have done, ठीक है? Now there is one part of the nature of image I have covered. Okay, the real and virtual nature. Now what about the size of image? Okay, size of image. size of image is given by m is equals to hi over ho. ठीक है, again if hi is greater than ho, hi is greater than ho, let me tell you with the this example. If this ratio, this is 7, this is 6, so 7 is greater than 6, so this quantity will come out greater than 1. ठीक है, in similar way if hi is greater than ho, then this ratio would definitely, if hi is greater than ho, then this m is come out to be greater than 1. And for more specific value, you will write it as mod of. So if mod of m is greater than 1, which means the size of the height of image is greater than the height of object, means हमारा जो image बनेगा वो क्या बनेगा, image will be larger. ठीक है, magnified image बनेगा हमारा. Got it? So I'm writing it here. M is equals to mod of m is greater than 1, then magnified image we got. Magnified. Got it? And in similar way, mod of m is less than 1, then height of image is less than height of object, then we have a diminished image. Diminish. Diminish mean smaller than the actual one. ठीक है, diminished image we get. Got it? So this has to be the no roll over here. Yeah. Got it? Now, one thing more that I want to discuss with you guys is about the कि image सीधा बनेगा या उल्टा बनेगा. Image will be erect or inverted. So that also be tells by the magnification, that we also can conclude with the magnification. How? So that we are going to do right now. Okay. Until and unless अगर आपको इसमें कोई doubt है, you can ask just right here. ठीक है, for the better clarification of yours. Write this thing in the chat box. Okay, let me just check the chat box if you have any raise, any kind of. So I hope you are clear with this. Okay, because you have written no messages, I'm considering this is clear to you. So how to describe the nature of image? It will be erect. Will it be erect or inverted? So this will also depends on the height of image and height of object. How? Look, if height of image is measured in negative direction, height of image is measured in negative direction, and height of object is measured in positive direction, means plus ho. Okay, so this ratio will be come out as what? -1, negative. Okay, or less than 1. If height of image is less than height of object, then this ratio would come out to be less than 1 and negative. So if m is less than 1, okay, and negative also, the image will be, अब आप खुद ही सोचो, just think about it. Height of image is measured in downward direction to the principal axis. Height of object is measured in the perpendicular, in the upward position, which means that image formed is below the principal axis, which means the image has inverted. So it will be inverted. Okay. Okay. And if m is greater than 1, similarly अगर यहाँ पे greater than 1 आ जाए, then image is obviously bigger than object and inverted, negative. But if m is what I say, it is positive, then image will be what? Erect. See, क्योंकि HI is also positive and HO is also positive. So this will give you a erect image. Okay, got it? Just give me 10 seconds. Sorry for keep you guys waiting. Okay, so let's just move on. If you have any doubt in this, you can just ask in the chat box. Okay, so here we have the image found by spherical mirror. So I have summarized this. ठीक है, अलग अलग ड्रॉ करने से बेहतर है, we would have a summarized view of it. ठीक है, so firstly I will discuss this column. ठीक है, so please pay attention to this. If object is placed in one region, in first region, means here, if object is placed from infinity to center of curvature, if object is placed between infinity to center of curvature, then where will be the image found? Image found in the second region. Means this is the second region we have. Image found in between the center of curvature and focus. ठीक है, सिंपल सी चीजें याद रखनी. If object is placed in one region, first region, then image will be formed in second region. And how the image will be? Image real होगी कि virtual? Because this image is also lie in the side of the रिफ्लेक्टेड रे. ठीक है, यहां से इंसिडेंट रे आई होगी, देन रिफ्लेक्टेड रे एक्चुअल मीट हुई होगी. ठीक है, इसके लिए भी वन ऑफ द ट्रिक दैट आई हैव टेल यू, इफ image is formed, image is formed and if this image lies beyond the pole, पोल से इधर है, ठीक है, कहीं भी है, बट पोल से किस साइड में है? This side will be the left hand side. So if the image formed in the left hand side of the pole, this will be a real image. ठीक है, so image here will be real. Erect होगी कि inverted होगी, ये कैसे पता चलेगा? Erect होगी कि inverted होगी, सीधी होगी या उल्टी होगी? That would be tells us about the M. If M is positive, then image will be erect, and if M is negative, then this will be a what? Tell me. If M is negative, then this will be a inverted one. Okay, so image from this will in this direction. So this height of image is negative, and this height of this object height is positive. So the ratio of this will be a negative one. So image would be the negative one. Okay. Also, can you please tell us by this? Can we encounter this thing with this formula? This V is negative, minus of V, and this U is also negative. So this cancel, it will gives you a negative value. So M is negative for the first case because both V and U have the same direction. So M is equals to minus V upon U, and both V and U have same direction. So M is negative. If M is negative, then the image found will be inverted. Okay. Now, what about the size of the image? What about the size of the image? So you can see here, if the mod of M is greater than 1, okay, then it will be a magnified image, magnified. And if mod of M is less than 1, it will be a diminished image. ठीक है. Now tell me, by this formula, if I take mod of this, then it will be u v upon u. Here v is less than u. V is less than u, obviously you can see. ठीक है. If v is less than u, then m, then this ratio v by u is less than 1. ठीक है. So the image would be diminished one. Got it? For this, for the inverted nature, we will have the m is equals to negative here, and for this mod of m is also less than 1. If object lies in second region, the image formed in the first region, vice and versa. If object in first region, image in second. If object is in second region, then image formed will be in the first region. ठीक है. रियली होगी बिकॉज दोनों सेम ही डायरेक्शन में है. ठीक है. और इन्वर्टेड होगी या इरेक्ट होगी, अगेन एम से हम पता करेंगे. ठीक है. फॉर इन्वर्टेड नेचर वी हैव सीन दैट v and u both are measured in the same direction में है, then m is equals to minus of v upon u. These are the same direction, so this negative role play the role. Okay, so m will be negative. m negative हुआ, then this image will be inverted. Magnified होगी. क्यों होगी magnified? Because in this, if object lies here in this region, okay, if object here, then this distance is u, and image formed in this region, then this distance will be v. So definitely here v is greater than u, so this ratio would definitely come out to be greater than 1. So that is why the image formed here is the magnified one. Got it? Now if I move on to the next part. Okay, so in the next part, if the image lies in the third region, what would be the third region? It is between focus and pole. So if image lies between this, sorry, object lies here, this is the object, so the image form will be in the fourth region. Okay, got it? So you can tell here that if object is in third region, the image formed will be in fourth region. And similarly, if object lies in fourth region, image formed will be in the third region. Got it? Virtual banegi if object present in the third region, image will be formed in fourth region. This image will be virtual one because it is on the back side, on the polished side of the surface where no ray can pass. So there is not actual intersection of reflected ray. There is only the virtual reflection. ठीक है. तो यहाँ पे वो appears to meet हो रही है. So that is why this is the virtual. Erect होगी. All this can be tell by the magnification m again minus v upon u. ठीक है. So you can tell here that v is considered to be positive because v has to be measured in the direction of reflected ray, positive. You have measured here in negative direction, so minus u. This minus and minus will cancel it out, so this will be a positive value. So magnification is positive. Magnification is positive. So this would be a erect image. Magnified image, yeah, definitely magnified hogi because here in this case, this v is greater than this u, and you just have to remember this. Okay, so for this mod of m is always greater than 1 for this. So here the magnified image will be formed. Mod of m is greater than 1. And for the next part, if object placed in fourth region here, so the image formed in the third region. Image is real here. Okay, so an object plays a virtual role. ठीक है. So erect होगी कि inverted होगी? Again m is minus of v upon u. Here v is negative but u is positive, so minus of v upon u. So this minus will plus, so it will be v upon u. It is a positive quantity. So m is positive. means direct image. And diminished, yeah, definitely the mode of M here is less than 1. Got it? So this is all about the image form. And one thing that I have mistaken here, this is not virtual, this will be a real image, because this is the actual meeting of reflected ray here. Okay, so this is the real image that has to be formed. Got it? If you have any doubt, you can write it in the chat box. Now the refraction part we have to deal. What is refraction? Okay. Refraction, we have deal with reflection. Reflection, what is reflection? A ray is coming and it is going back after the interaction with the boundary. Why it is not passing? Because the surface is polished. Okay. But what if the surface is not polished? Surface is transparent. The medium through which the ray is striking is transparent. Then this ray of light will penetrate in this medium. Okay. And that phenomena is termed as the refraction of light. Okay. जब भी कोई ray enter करेगी, it will strike with the boundary and penetrate through the medium. Okay. That phenomena is termed as refraction, but it is the incomplete definition of it. What is the perfect definition of it? When light comes and strike a transparent medium, the path of the light has been deviated. So this deviation of path caused by the phenomena of refraction. Okay, got it? You can also read this in the definition. When a light ray travels from one transparent medium to another, it deviates from its original path. And the phenomena of change of path of light at the medium of separation is called as refraction. Got it? So from this example, you all have must seen this. जब भी आप कोई पेन किसी ट्रांसपेरेंट ग्लास में रखते हैं, and which is also made up of glass, okay, which is also transparent, so you will see that this pencil will appear to be bent over here. Okay, this is because of the refraction, because light ray is coming in this direction. Okay, and after reflection it is changing its path, so this would appear you कि ये यहीं से ही आ रहा है, but this is not the actual path, this is the path after deviation. ठीक है, let me tell you more about this. This is the incident ray we have. Okay, this is the incident ray that we have in this figure. Just a second. This is the incident ray we have. Okay, this strikes the boundary of a transparent medium and it is coming right through from the air, or I am considering the substance one here is air. So it is directly coming from the air, strikes this medium at this point of intersection, and after the striking it penetrates in the medium, but with the deflected path. अगर ये एक्चुअल में जाती तो इस तरह से जाती सीधी, but it has deviated from its path. Okay, got it? So this phenomena of deviation of path of light after striking a transparent medium, okay, is called as refraction. So when a light ray coming from one transparent medium to another transparent medium, the path of the light ray has been deviated, and this phenomena is termed as the refraction. Okay, got it? Now you can ask what is the actual cause of this, how this light is bending. Okay, so when you change the medium, the speed of light will change. Okay, because the speed of light will depends on the medium, because light is also behaving as a wave. So wave has a nature that speed of wave depends on the medium. Okay, so here speed of wave depends on the medium. So if we got the change of medium, the speed of the wave will also change. Similarly, light is also behaving as a wave. Okay, light has multiple natures, we can say, but at the time it is behaving as wave. So when it changes its medium, the path of it would be changed because of the change in speed. Got it? And this speed change will be a further higher discussion. Okay, why it is so? I'm telling you for the information of yours, because light is an electromagnetic wave. So the substance is made up of, any medium is made up of atoms, and atoms has electrons. That atoms has positive and negative charge both, which causes the electric field development. Okay, this light ray is also carrying electricity, because it is the combination of electric field and magnetic field. So that electric field will cause the change in the electric field of medium. That is why this, the ray after refraction getting deflected. Okay. Okay, then we have the laws of reflection over here. Laws of reflection में there are two laws again, similar to the, जैसे रिफ्लेक्शन में दो लॉ थे, यहाँ भी similar, we have two law. First law is very simple, incident ray, normal ray, or normal to the surface, incident ray. Let me just draw it, just a second. Yeah. So here we are, this is the medium, like this is air and this is some glass. Okay, this is the normal to the surface, this is incident ray, and after reflection it is getting bent. Okay, from its original path. This is the normal that we have. So yeah, incident ray, normal, and refracted ray, not reflected one. Refracted ray lies in the same plane. You can see it. These all are lies in the same plane. ऐसा नहीं है कि after reflection, like this is the ray coming, after reflection this is going in this direction. No, it is going in this direction. After change it will move along this path. It will not coming towards you. Okay, so that is the change of plane, but it is not happening here. Okay, so this is the first law of refraction. Got it? Now what is the second law? Second law is also termed as the Snell's law. What does it tell us? It tells us about that the ratio of sine of angle of incident to the ratio or to the sine of angle of refraction is always constant for a given color. Okay, means sin I divided by sin r is equals to mu2 by mu1. What is this mu2 and mu1? Mu2 and mu1 are the refractive index of the related medium, and this will also termed as 1 mu2, which is nothing but refractive index of medium 2 with respect to medium 1. So you have to keep learning it, like how it is pronounced. 1 mu2 means refractive index of medium 2 with respect to medium 1. This is also termed as the relative refractive index. Okay, got it? No, the refractive index of medium is defined as the, what is the refractive index? So it is defined as the factor by which the speed of light is getting reduces as compared to the light in vacuum. Okay, so whenever the light strikes, a medium rather than air or vacuum, okay, which is optically denser than the other part, which is optically denser than the other one, so light ray will feel a change in the speed of it. ठीक है, क्योंकि लाइट की स्पीड बढ़ तो नहीं सकती, it is always constant 3 into 10 raised to the power 8 meter per second, but it can reduces. And which factor reduce it? The refractive index of a medium. So that is why mu here is the ratio of speed of light or velocity of light in vacuum to the velocity of light in medium, C upon V. And this is also termed as the absolute refractive index. This is not the absolute because it is the reference. You have taken a reference of medium 1 to measure the refractive index of medium 2. So this is the relative nature of relative property of refractive index. It is not the absolute, but here it is the absolute. Okay. So from here you can see that mu is equals to C upon V. Got it? You all know that this is a very beautiful formula and I have discussed it. If you remember it, I have discussed this formula in the properties of light. V is equals to n lambda, where n is the frequency and lambda is the wavelength. Okay. This will also true for C, speed of light, n into lambda. I am giving this lambda as lambda 1 and this is the lambda 2. Okay. Or I must write it as lambda 1 and this is at lambda 2. Okay. So if I put this value in this, what is the C? C is n because frequency of light is not going to change. Okay. N lambda 1 divided by n lambda 2. So n and n will got cancel out. So mu is also C upon V n upon, sorry, lambda 1 upon lambda 2. Okay. Got it? So this is it. This is all about the refractive index that we have. Okay. Now, for the better understanding of refraction, what is refraction? So, जब भी कोई ray, whenever a ray coming from a rarer medium, optically rarer, ठीक है? Tell me what is rarer in air and water? Obviously, you can feel it. Air is more rarer than water. Okay. So if this ray is coming from the rarer medium, okay, and going to the denser medium, then this ray bends towards the normal of the interface. Okay, normal की तरफ bend होगी. But when this ray going from denser to rarer medium, it moves away from the normal. Okay, for numerical value, for the numerical, या for question solving, for question solving, what you can do, you will apply the Snell's law. How? Just multiply this mu1 with the sin I. You have to take mu1 and sine of this angle. This angle is the angle of incidence. And this R is the angle of refraction, not reflection. Okay. So for the question solving, what you can do, you can just multiply this mu1 with sine of this angle. Mu1 sin I is equals to, again, what is the refractive index of this medium? It is mu2 sine R. Okay. This you have to keep in your mind. Again, for this, if I apply this Snell's law, what is the refractive index here? Is the mu2 sine I is equals to mu1 sine R. Okay, got it? You have to take the refractive index, multiply with the angle of incidence first, with the refractive index of that particular medium, and for the below side, for the another medium, you have to take the refractive index of that medium, multiply with the angle of refraction. Okay, sine of the angle of refraction. Got it? Okay. So Yeah, refractive index. The relative part I have to tell you. In the relative part, this mu2 by mu1 I have termed as 1 mu2. This is the refractive index of refractive index of I am writing it I refractive index of medium 2, not 1. You have to going in this direction. Medium 2 with respect to medium 1. Okay. Suppose it is written as A mu G. What does this mean? G means here is glass and A means air. So you will write it as that mu G by mu A. Similar way, to this quantity going to be in the what numerator, and this quantity going to in the denominator. Similarly, this back side is the numerator, this front side is the denominator. Got it? So this is the nothing but refractive index of glass. Refractive index of glass with respect to what? With respect to air. Got it? Now I have tell you, if the ray is going rare to denser medium, it will bend towards the normal. Okay? And if the ray is going from denser to rarer medium, it moves away from the normal. These two things you have to keep in your mind. Now solve this question. Okay? We are going to solve this question. Got it? If you have any doubt, you can ask. In the previous slides, if you are troubling with any doubt, you can just ask. Okay? And I'm waiting for your response. After you get the response, after I get the response, then I'll start solving this question. Please tell me that the previous slide, the previous concept is clear to you or not. Okay? Tell me, Swati, are you there in the class? There are many people in the class, na? So tell me, have you got this or not? Okay, Swati, you got this. Antara Sarkar, Charanya, Thanu, Pooja, Jasmine. All of you, I'm asking all of you. Okay. Have you got this or not? Okay, okay, okay. It's good. Okay. That's why, that's the reason you are paying attention to the class. Okay. Now solve this question. This is also for you. Okay. For the clarification of refractive index. Okay. If you find any trouble with any concept, you can just directly reach to me. Okay. From the chat box, you can just ask. Okay. Now, as I have told you, that for solving the question, you must have write the data first of all. What is given to you? So what is given here? The given data. Given data here is the refractive index of glass with respect to water. देखो आ गया ना? This is what? Tell me, this is absolute refractive index or relative refractive index? Just tell me in the chat box. This quantity that is given to you, the refractive index of glass with respect to water, what is this? Is this the absolute one or the relative one? Come on, make a very first response. Swati, Shri Lakshmi, Charanya, Pooja once again. So what is this? Is this the relative refractive index or the absolute one? बताओ बताओ भाई. I'm waiting for your response. Tell me. Okay, so that means that the refractive index, you didn't get it. Okay. Look, when you measure the refractive index with respect to some medium, which is not air, then the refractive index is termed as the absolute one. But air को छोड़ करके, if you measure the refractive index with respect to any medium, ठीक है? So here we have glass and water, so there are not air there. So this refractive index will be termed as relative. And Akhil Kolati has given the right answer. Okay, so I'm clapping for you. It's a good answer. Okay, so what we have given here, just pay attention to the class, and if you have any doubt, you just ask, na. Okay, so refractive index of glass with respect to water is given. So how we are going to write it? This is mu, the refractive index of glass. So first term we have to write here with respect to water, which means mu g divided by mu w. Okay. If the velocity and wavelength of light in glass are, if the velocity and wavelength of light in glass, velocity in glass 2 into 10 raised to the power 8 meter per second, and the wavelength in glass is 4000 angstrom. Then find the velocity and wavelength in water. Lambda of water we have to find out, and velocity of water we have to find out. Okay. We know that mu is nothing but the ratio of speed of light. More specifically, it is given as v1 by v2. Speed in one medium divided by speed in the another medium. Okay. So first medium we have to take speed in medium 1 divided by speed in, and किसकी स्पीड, लाइट की स्पीड इन द मीडियम 2. ठीक है. So here we are provided with W mu g. So we have to consider the velocity, yes, speed of light in glass divided by speed of light in water, because this is the simple ratio. This is the speed of light in this medium 1, and this is the speed of light in the second medium. So this mu g, W mu g tells us what? It is mu g by mu w. So you can also write it here as, because mu g is nothing but speed of light divided by, just a second, speed of light divided by speed of light in glass. So mu g we have this. For mu w you can write c by v w. ठीक है. So if you take the ratio of it, what will you get? Mu g by mu w equals to c upon vg, c upon vw. This vw goes in up direction and this will comes in down. So this is vg. ठीक है. Now what is provided to you? You have the value of W mu g, ठीक है, which is nothing but 9 by 8, ठीक है, and you have provided with the Vg, so you can write it as mu g by mu w is equals to Vw by Vg equals to 9 by 8. Okay. Now this is 9 by 8, and you have one quantity also known to you, which is nothing but Vg. So we will take this ratio only. Vw divided by Vg is given to you 2 into 10 raised to power 8, and it is 9 by 8. So what is the value of Vw? Vw is nothing but 9 by 8 times 2 into 10 raised to power 8. 2 4 ja. So Vw here is 9 by 4, 10 raised to power 8 meter per second. ठीक है. Got it? Now, if I talk about the ratio of wavelength in this, what it would be? The ratio of wavelength. Again, we know that mu g by mu w is nothing but the ratio of speed of water and speed of light in glass. It again we will use that formula. What formula? Formula is V is equals to n lambda. So from here we can say that this VW and this VW and VG is nothing but what? N and N got cancelled out. So it is the lambda of W divided by lambda of glass. Okay. And that is provided to you. That has been provided to you. Let me make some space over here. Okay. So VW by VG is equals to mu W by mu G. Sorry, mu G by mu W. Mu G by mu W, which is 9 by 8. And also this ratio is also equals to lambda W by lambda G. Okay. So you have the value of lambda G over here. What is 4000 angstrom? So just take this ratio. Now, what is the value of it? Just try to calculate it. Lambda W by lambda G is equals to 9 by 8. Okay. Lambda W, we have to find out. It is nothing but 9 by 8 multiplied with lambda G, and lambda G is provided to you. 9 by 8 multiplied with 4000 angstrom. So you can just calculate it. It is 1000 divided by 4 to the 8. So it is 4.5. So it will be 4500 angstrom. Okay. So these are the answer to this question. If you have any doubt in any of the slide, you can just ask. Otherwise, the lecture has been over for now. So this is it from today for today. Okay. I hope you guys have understood it, what I have tell you. If you have any kind of doubt, you can just ask, or otherwise, thank you so much. Take care of yourself. I'm just stop presenting my screen now. Okay. Okay. Then thank you so much, Akhil Kolati. Thank you so much, Antara, Charanya, Akhil Kolati, Darshana, Swati. What is this? Snehit, Pooja, Jasmine, Thanu. Thank you so much, guys, for attending the lecture. Okay. If you have any trouble, you can just ask. In the next lecture, if you have doubt in this lecture, you can just also ask in the next one. ठीक है. सबको समझ में आ रहा है ना? The way I present, the way I talk. Okay.